In this video, let us continue to solve more problems based on sets. Alright, here we've got a question, a lengthy one at that I guess, which reads like this. It says, find the pairs of equal sets from the following sets, if any, giving reasons. So there are a group of sets here, A, B, C, D, E. So A equals open bracket, 0 close bracket, so that is one set. B equals X such that X is greater than 15 and X is less than 5. C equals X is such that X minus 5 equals 0. D equals X is such that X squared equals 25. E equals X is such that X is an integral positive root of the equation X squared minus 2X minus 15 equals 0. So all that we have to do in this case is just, solve the sets. Now this is already solved. A is, it can't be anything apart from 0, so that's done. B we can solve, C we can solve, D we can solve, E also we can solve. After solving, let's see, how many sets turn out to be equal to each other. And then write it separately as a pair and maybe give reasons why is it equal. That's all we have to do in this problem. So let's do that now. So here it is, A equals 0. Well, B equals what? X is such that X is greater than 15 and X is less than 5. Well, how can that be? How can a number be greater than 15 and less than 5? It can be greater than 15, less than 25. It makes sense. But greater than 15 and less than 5, well, it definitely doesn't make sense. So it is definitely a null set, right? So we can symbolically write it as B equals 5. Or, the bracket, write it as null set. So we haven't still found any equal pairs of sets as of yet. So let's see, what is C? C is nothing but X is such that X minus 5 equals 0, which means X minus 5 equals 0. Therefore, X equals 5. So C equals 5. That is what we've got from C. So next we've got D. D equals X squared equals 25. So X will be equal to plus or minus square root of 25. So X equals what? Minus 5 or 5. Right? So D equals minus 5 or 5. So that's D for you. Still not equal to anything. A is not equal to B, nor is it equal to C, nor is it equal to D. But neither of them are equal to each other. So finally, let's go to E. What does E have for us? Let me write it here. Well, we clearly have a quadratic equation here, x squared minus 2x minus 15 equal to 0. Solving this, we have x squared, x into 15 is 15. So, yeah, 5 times 3 is 15, right? So, minus 5x plus 3x minus 15 gives you 0. So, that means minus 5x plus 2x gives you minus 2x. At the same time, 5 times 3 gives you 15. So, I'm not going into details here because we've done loads of quadratic equation in the previous videos. So if you do not understand any part of the solving of the quadratic equation here, please do visit the previous videos in which we've solved simple quadratic equations. This is definitely a simple one. So now we have, solving this, we have, taking out x, factoring out x, we have x minus 5. And here you take out plus 3, again you have x minus 5 equal to 0. Factoring x minus 5 from this equation, we have x minus 5 and x plus 3. So we have two things here. So yeah, whatever I'm solving apart from these boxes is going to be E now. X minus 5 equal to 0 or x plus 3 equal to 0. So x equals 5 or x equals minus 3. But E says x is an integral positive root. So we have to consider only x equal to 5. So therefore, E equals 5. And I think we may have found equal sets here, at least a pair of equal sets here. And that will be E and, well, C here. So clearly you can see that E and C are equal. Therefore, there is a pair of equal sets, which is E and C. So E equals C. Clearly you can see Y here. Alright, so that is this problem. That ends this problem as well as this video. I'll see you in the forthcoming videos with more problems based on sets.